The ILC, or International Linear Collider, is a next-generation research tool for advancing our understanding of the universe. Scientists from around the world are already working to realize the project. In Japan, the Kitakami area in the northeast is a candidate site for the collider's location. The ILC will be a huge project, a 30-kilometer linear accelerator in an underground tunnel. Eventually, it will be extended to 50 kilometers. Inside the tunnel, electrons and their antimatter counterparts, positrons, will collide to create an extremely high-energy state of matter. At the heart of the collision, conditions will be similar to those 1 trillionth of a second after the beginning of our universe, the Big Bang, 13.8 billion years ago. This is a grand experiment. Let's take a look at the mechanisms. The ILC will accelerate and collide electrons and positrons. Electrons are emitted in bunches by a device called an electron gun. Their antiparticles, positrons, do not exist naturally in our universe. They have to be made from the electrons. The bunches of electrons and positrons are injected into a facility called the damping ring. As the particles travel around the ring, they are packed into very dense and narrow beams. The electrons and positrons are sent into loops at the far ends. From there, they are directed back towards the collision point at the center. Each arm of the accelerator is 11 kilometers long. Inside is a series of uniquely shaped devices, the superconducting accelerating cavities. The cavities are enveloped in liquid helium and cooled to minus 271 degrees Celsius to make them superconducting. This allows the particles to be accelerated with maximum efficiency. Just before colliding, the particle bunches are squeezed into tight, narrow beams. Then, during the collisions, electrons and positrons annihilate each other in a burst of energy, creating an array of new particles and new physical phenomena. At the point of collision, 2 detectors record precious information about every particle produced in each interaction. The ILC is a fantastic tool for observing the properties of elementary particles precisely and in great detail. In 2012, the Large Hadron Collider at CERN, Switzerland, discovered a long-sought particle called a Higgs boson. Some theories predict the existence of particles that have a slightly different nature from the Higgs boson. The ILC will be able to investigate this further. Then there's the riddle of the composition of our universe. The latest findings in astronomy indicate that the matter we're able to observe constitutes a mere 5% of the actual substance of the universe. That's the same proportion as that of the non-black jelly beans in this jar. The rest of the universe is composed of what's called dark matter and dark energy, but we've been unable so far to gain a real understanding of them. Again, the expectation is that the ILC can shed some light on these mysteries. New technologies developed in connection with the ILC project are also expected to have a range of industrial applications. Research using the accelerator has already contributed to drug design, development of new materials, and the study of rare earth metals. And accelerator technologies are used in particle radiation therapy. and non-destructive inspection. Iwate Prefecture's vision is one of synergies between the ILC and the entire region, building an international community that will exercise global leadership in science and technology in the 21st century.